So the test is going to be like this. If you get greater than 70, I'll give you 15 points. Now that's before weighted points, so it's 45 out of 300. So that's 15 points, right? So that makes it 70 and 85, right? If you get greater than an 80, it'll be 20. If you get greater than a 90, it'll be 25. And you get greater than 100, it'll be 30. Clear? Yes? So that's a lot of points. That's a lot of points. Some people's grade fell an entire letter grade on the solutions test. But I'm not curving that solutions test for everybody. That solutions test, I will curve that solutions test based on your ability to take the acid-base test. Sorry. If you don't know acids bases, don't even bother. Fatima.
So if you get 70, you add
15, yeah, you get 85.
What if you get somewhere in between?
No, greater or equal to 70, girl.
Oh.
70, 71, 72, come on, please. 79, okay? Okay, you don't get any points if you get 69. 68, 69, you don't get any points. Clear? So you got to get better than these grades to get that many points. Clear? And if everybody does really well, I don't mind making that like 16, 17. It doesn't bother me. But if I get nobody, if nobody bites on that, nobody bites. Understood? Okay, Rashid, you want to sit down, please? Unless you want to make a speech. No, sit down. Okay. All right. So remember, these problems you should be doing regardless. I am not going to tell you what the other corresponding numbers are. You should be doing these. You can use the online resources, etc. Okay, now. Let's do 82. It says, the pH of a 0.5, the pH of a 0.5 molar nitrous acid. So it's 0.5 molar. Okay, we're going to get into some other problems here. Okay, 0.5 molar nitrous acid. Right, 0.5 molar nitrous acid. All right, the pH is 1.83. Okay? Right? They want to know the Ka. Let's talk about Ka just for a moment, okay? Let's talk about the Ka. So, the Ka, this is the equation. Now, this is very important. So, I know that you've been pretending to look participatory, but now you really have to be. This is the next hard thing that we're going to be doing. If you get this, this is the middle third. Understood? There's three things on this that make this chapter a major problem. The first one, I think we've cracked. This is the middle third, okay? We'll make it equilibrium. H plus, I really mean hydronium, but okay. And then, all right, yes? You okay with that? Now, the Ka, what's the Ka? The Ka is a mathematical expression. Kb, same thing. The Ka is when you have the H plus. The Kb would be when you have the OH minus. Okay, let's write a different color. Now, you ready for this? This is cool. Ka equals okay, the Ka equals, are you ready? This is important, this is big. Is it coming up? Okay, now you can read this mathematically. Remember, brackets mean molarity, correct?
Yeah.
Okay. the molarity of the H plus times the molarity of the anion, okay, in this case nitrite, divided by the molarity of the solution. Okay, you get that? All right, now, what are these values? Well, we know that the pH is 1.83, correct? So don't we have a way of finding out the concentration of the hydronium ion concentration? What is it? In other words, I know that the hydronium ion concentration is going to equal 10 to the negative pH. So do that right now. Where's my I don't know where my calculator is. Where is it? You have one? Where is it? Oh, there it is. All right, so it is going to be, anybody lose a calculator recently? Okay, did you leave it in here?
I'm not sure.
Okay. All right, it's going to be 10, so you go second, and then you put in negative 1.83, so 10, so you go second negative, and then log, so it's 10 to the x in blue, and then you put in negative, hit negative, and then 1.83 equals, right, equals 1.48 times 10 to the negative 2. You get that? Yes or no?
Oh, yeah, wait.
Okay? You get that?
So second log of negative 1.82.
Okay?
Yeah.
You all right with that? All right, now. Shall I show you the easy way or the hard way? Yeah, I think I'm going to show you the easy way right now, and I'll explain why the easy way is legitimate. Okay? All right. Can I erase this?
No.
No. Okay. I guess not. All right, let's do... so I know that this is going to be, what? 0.5, right? Correct? Right? And I know that this, let's take it out of scientific notation so it makes a little bit more sense. So it's going to be 0.0148. Is that right? Is that right?
Yeah.
Right? Molar, right? What, if this is 0.0148, what would this be?
1.508 minus.
Yeah, all right, but wait a second. If this is 0.0148, what is this?
1.6.
No, listen to me. Is this a balanced equation? Is it balanced?
Yeah.
Okay. If this has, let's say it's 1,000, let's say it's 1,000 milliliters. If this has, isn't this 1 mole here, 1 mole there? So if this is 0.0148, what's this? I want to know what the value of this is going to be. This is 1 to 1. If this were 1 mole, how many moles would this be?
1 mole.
1 mole. If this is 0.1 moles, how many moles would this be?
Oh, I get it now.
This would be 0.1 moles. If this is 0.01 moles, how much would this be? 0.01. If this is 0.0148, what would this be?
0.0148.
So if I break down one of these, aren't I going to get 1 to 1? 1 to 1? Aren't I? Yes. So the answer here is 0.0148.
That doesn't seem like a balance.
Yes or no?
It doesn't seem like a balance equation.
Because it's weak. It's a weak acid. If this were a strong acid, you would get 0.5 and 0.5. But it's a weak acid. That's the whole point. It's a weak acid. The only reason you determine the Ka, which is called the dissociation constant, is the only reason you do that is because it's a weak acid. You want to know how weak. A strong acid doesn't need one. Why? Because it's 100% dissociated, so we don't care. But a weak acid is weak, so we need to know what is the precise amount that's going to be in solution, because we don't know exactly how much. If it's hydrochloric acid, we know that it's going to be completely dissociated. We don't care. You say to yourself, I put in 0.1 moles. Well, how much? If I say I put in 0.1 moles of hydrochloric acid, so somebody says to you, well, how much H plus do you have? And you say 0.1 moles. Well, how do you know that, Mr. Darcy? Well, it's completely dissociated because it's a strong acid. Well, is this a strong acid? Well, how much is there? What happens if I'm going the other way? Well, I need the dissociation constant to let me know, well, how much is going to be there. Okay? All right, now, this is very empirical. I can do this in a lab. Okay, now, so I have these values, correct? Now, I said, where are you going? Who has to leave? Who? Why? I have no memory of it at all. Why are you leaving now?
Because we go to the device where I help do all the setup.
Can you give me like just about 4 minutes? Okay? This is, I'm like right there. I'm right there. Okay? Okay? I'm right there. Thank you, Mr. Darcy, for caring about my chemistry knowledge. You're welcome, Andrew. Andrew's giving me like this face that could like, I feel like my face has been ripped off by just looking at me. Okay. Now remember, if I produce 0.0148, don't I have to subtract it from there?
Yeah.
I do, right? Yes or no?
Yes.
But I'm not going to do that just for now. I'll do it when you guys leave, I'll do it. Because sometimes the acid is so weak, that's so small, it doesn't matter if you subtract it off. You see? Because that's so small that the effect is negligible. Okay? So, what I say is,
Mr. Dorsey, did you say even if you have small changes, it can be drastic?
yes, I did, but it's relatively speaking. Relatively speaking. In other words, this changes here relative to this. Not in terms of, am I going to get a yeast infection in my colon? You know, those are small changes in pH, yes. But this is, I'm looking at this relative to that. But that's a good point. So I would say 0.0148. Remember, I'm doing this mathematically, right? Isn't that squared? Because it's this times this, right? Divided by 0.5. What does that equal? And then we're going to do it the long way after you leave. And you're going to look at the film to see. Okay? Because the long way is quadratic equation. It's annoying. What's the problem? Okay, is it still working? Okay, so what's the answer? Anna, help me out here. Do you want to leave or do you want to, you know?
4.38 times 10 to the negative
4.38 times 10 to the what?
4.
Excuse me, thank you, it's low battery. Rash is trying to be very helpful. And it's like walking in the middle between you and me. You know? All right, so 4.38 times 10 to the negative 4. Okay? Unit labels here? Or no? Okay? That equals my Ka. Okay? Now, what we'll do after you leave, what we'll do is we will see if that makes a difference. Okay? I'll shut this off, and then I'll do it, because the long way, Anna and Andrew, is a quadratic equation, quadratic expression. It's a little longer. It's annoying, but you guys can do quadratic equations, correct? Yes or no? Okay. All right. Speaking of quadratic equations, I think you're being asked to leave by...
Yeah, I came because they are already leaving.
Yes, well, that's okay. We were doing something more important, like determining a Ka.
That's
Okay.
very important.
That is very important.
Come on.
Exactly. And I also put stuff about the curve. This is, they're like looking, like wondering who this is. You guys know who it is, but you don't. Who am I talking to? Okay.
Hi.
Hi, he said hi. Okay.
Hi.
All right, so now we'll look at the quadratic equation on the next film, okay?